From the knife of your kitchen to the car in your garage, you are going to find steel in everywhere you look. It is very hard to imagine your life without steel. So steel and metals are used in many other applications that is directly or indirectly related to your life. They all vary and they are all used according to the properties that they are set for. For example, you can't use the steel that is made for your knife for making a car because there are certain properties that are being changed to make the steel for your knife. All these words like strength, ductile, malleability, stiffness, toughness, what are these? You are going to understand all these property in this video with a very simple example and with a very detailed information. While we take this ride, let me know in comment section the top 3 uses of steel that you are engaged in day-to-day life. In this video, we are going to learn about the different properties of steel. So you already know, steel is the most popular element for making the weapons in the medieval time, right? So after copper, the first examples of weapons are steel. And after steel, we started the Iron Age. To understand this, we need to understand two simple phenomena that are known as stress and strain. Let's understand what is stress, and after that I will explain you what is strain. And based on these two phenomena, we decide how strong the material is or how the strength is measured for a certain material. When you apply force on certain system, it will deform, it will change its size, it will change its either width or length, one of the dimension of the object. So in short, when you apply pressure, it changes its shape. So that is basically what we call stress when it comes to applying force. So the change in the dimension due to the force is called the strain. Difference between the change that happened and the original dimensions is known as strain. So every material has a different way of behaving under the pressure or behaving under stress. It all depends on the molecular structure or metallic bonds in between the structure. So based on the different types of the force that we apply, there is a compression force, there is a tensile force, and there is a shear force. So these are different types of stress that we can apply. There are lots of different stress, but these are the main stress that we can apply to the object. And object behaves differently with individual or every single stress type. So this behavior determines the property of material. For example, whether material is strong or whether material is ductile. Is it hard or is it malleable? So all that kind of question you will get answered by understanding the material behavior under the stress. So normally we take a unit sample and then we put it into a tensile strength tester. So this machine holds the piece together and pulls it on the both sides. So this is how you test the deformation of the material and how long that can survive. So when we put the sample into a tensile strength, up to a certain point, it can still regain its own original shape. But after a certain point, it starts having a permanent deformation, and after some point, if you pull, it goes into more deformation, and at some point it will break. With the application of force and the change in the dimensions, we use stress-strain curve, which can be measured with this curve that is shown in the video, and we understand the behavior of change in the metal or in the sample that we have. So using this graph, we determine the Young's modulus, which is nothing but a sustainability of the metal to come back to its original form under the force. So this graph is useful to find out what is the deformation point, at what point the material gets back to the shape, and at what point we can break the material. Now this is how you find the stiffness of the material. And now in the stiff material you will find a graph like this. But when you have just the opposite of the stiff material, which means like a rubber-like material, you will find a graph like this. And this graph you can determine what material is rubber-like and what material is stiff. We know what is a rubber-like and stiff material. Let's understand what is tough and what is brittleness. Now in between these two stages, there is a stage which is called as the ductile stage. So in this stage, what happens is you can put the material under stress and it will regain its shape until a certain point, but it has a high deformation point. That means if you can stretch that material along, you will find a huge permanent deformation in those material. So those material are called ductile material. Interesting thing is when they are deforming and when they are under the stress, what it does is it absorbs the energy of the stress, or it absorbs the force that is applied on them to convert them into a new shape. Now just the opposite of that is the brittleness. So brittleness has a graph like this, which means you can apply certain pressure and it will break without even deformation. Do you know these properties are actually changing with the temperature? So there was an example in the World War where quite a few ships just snapped because they were made of steel and the water temperature was too low, and the steel became brittle and it snapped into two pieces. Another important property of metal is the hardness. So the hardness is nothing but an ability to dent itself or put a scratch into the surface of the metal. So this hardness is checked using the Rockwell hardness test. This property can also be changed using the temperature. So one of the examples that you will see is in the movies where they are sharpening the sword using the heat. So what that does, it gives a hardened surface outside the steel surface and still have a good tensile strength, tough and stiff material that can absorb the shock. All the knives, they have hardened surface. All the industrial tools have hardened surface, so they can survive long-lasting stress. Thank you very much guys for watching this video. In my next video, I'm going to explain how all these properties can be changed and how they are changed using the alloying element into the steel. Please don't forget to like, share and subscribe. It really helps us to keep the motivation going.